An AM station broadcasts its show at 1010 kilohertz. Calculate the energy of the photons emitted by this station. So the energy of the photons, on an exam, you would have access to your equation sheet. So in this case, we have a frequency, and we want to know the energy of the photon. So E photon is what we care about, and there's an equation where Planck's constant times the frequency will give us the energy of the photon. Planck's constant would be found on a constant sheet in my course. So 6.626 times 10 to the negative 34th joule seconds. So we now have a frequency, and we have Planck's constant. Oops, this is in kilohertz. Getting ahead of myself. But we do need to make this in hertz because this is a little bit higher than we'll actually cancel out with this. So we're going to take our 1010 kilohertz. 1 kilohertz. There are 1,000 per second, which we would like to be able to cancel that out. So we have 1.01 times 10 to the 6th per second. So let's calculate the energy of the photon. We're going to multiply Planck's constant times this frequency, which you can kind of see. So we're going to have 6.626 times 10 to the negative 34th joule seconds. We're going to multiply that by our frequency, which is 1.01 times 10 to the 6th per second, so that our seconds will both cancel out. And then we can plug this into our calculator, which is 6.626 e to the negative 34th multiplied by 1.01 e to the 6th. In this case, we get 6.69 times 10 to the negative 28 joules. So if we double check our significant figures, there are 3 in this and there are 3 here. So the energy of a photon released by this type of a frequency is 6.69 times 10 to the negative 28 joules.